As we know, sound is produced due to the vibrations in our body, but all the sounds are not audible by the human ear. We can hear sounds of frequencies in the range 20 Hz to 20,000 Hz, means all the sounds which are less than 20 Hz and more than 20,000 Hz are not audible to us. Therefore, the audible range for the normal human ear is 20 Hz to 20,000 Hz. Sounds which have frequency more than 20,000 Hz are ultrasonic sound. Ultrasonic sounds are not audible to human ear. Therefore, we cannot hear ultrasonic sounds. Animals like dogs, bats, monkeys, etc. can hear ultrasonic sounds. Dogs can hear the sound up to frequency of 50,000 Hz. Bats can hear up to 100,000 Hz, due to which bats can easily move from one place to another at night without colliding with any other object. Bats keep on producing ultrasonic sound while flying, which, when collide with any object in their path, reflect back. Bats hear this reflection and identify that there is some obstacle in their path. So they change their path and move easily. Infrasonic or subsonic sounds are the sounds which have frequency less than 20 Hz. Infrasonic sounds are also inaudible by the human ear. For example, sound produced by a pendulum of the clock. It makes one vibration in 2 seconds, which means that time period is 2 seconds here. So frequency is equals to 1 upon time period. Therefore, frequency will be equals to 1 upon 2, which is 0.5 Hz. So in this case, frequency is less than 20 Hz. That is why we cannot hear the sound produced by the pendulum of the clock. Therefore, sounds are classified into three types: infrasonic sounds, which have frequency below 20 Hz, audible sound, which have frequency in the range 20 Hz to 20,000 Hz, and ultrasonic sounds having frequency more than 20,000 Hz. Characteristics of sound. There are two characteristics of sound: loudness and pitch. In today's class, we are going to discuss the first characteristic of sound, that is loudness. Have you ever thought that why a louder sound is produced when you strike a drum hard, but when you strike the same drum gently, a low sound is heard? This happens because when you hit the drum hard, the membrane of the drum moves more from its rest position. That is, the to and fro motion of the membrane is more in this case. This to and fro displacement of the membrane from its mean position is its amplitude. Now compare the two sound waves given below. You can observe that the displacement of wave A is less than the displacement of wave B. So we can say that wave A has greater amplitude than wave B. As the amplitude of the wave increase, the loudness of the sound will also increase. So loudness depends on the amplitude of the wave. Greater the amplitude of vibrations, louder is the sound produced. That is why when we strike a drum gently, a feeble sound is produced, because here the amplitude of sound wave produced is less in comparison to the amplitude of sound wave produced when we strike that drum hard. Loudness also depends on the area of vibrating object. If the vibrating object has greater area, louder sound will be produced. That is why in temples the sound produced by a bell with bigger case is louder than the sound produced by the bell with small case.